how do we take the cards, the task cards, and not use them in a way that they turn into a worksheet and
Right.
become excessively annoying to your kids, because they can be just as annoying as worksheets can. So we're going to just play the one game that, of course, I did this training, and it was after I did the training that I had a light bulb moment happen, that like pretty much that's all we're doing with Gatenio is playing one giant substitution game.
Okay.
So that's all we're going to do. So how the substitution game is played is I'm going to do let's do, what sentence do we want to use? Let's give me a statement, an addition statement. So like 6 plus something.
6 plus 3.
Okay. Equals
9.
Okay, so here's how the substitution game works. We're going to, our first rule, so we're going to set up the rules ahead of time. And our rules are, and you can make whatever rules you want. You're an adult and your kids are, you guys are in a family, and you can pick whichever rules you want. But for the first time we play, the rules are going to be that you must replace only one number with another way to say that number. So we're going to play with it with rods first, because this is how little kids, we're going to play with it just like you would play with little kids, and then we're going to play it all the way up to playing it with big kids. So you have to pick a rod and replace it with 2 other rods. So pick your rod.
So do I have to click on the screen or just
No,
tell
you just tell me and I'll put them in.
Okay. So replace the 6 with 2 plus 4.
Okay. Andrea? So wait, so then what we would do is we would continue building the rest of the, you just, so that you can see how this is done. So now you have to change one other one. Andrea, your turn.
Replace 3 with 2 plus 1. So red plus white.
And we need 4, a 4, and a 2, and I would put in a 9, and now I'm going to change, so let's go here. We have 4. And then all right, so here we have, so here's our, you see how this works, right, Jeanette?
Oh, yeah.
Okay, so how could we change this? So instead, eventually what's going to happen, if you figure this out, which is actually a really good revelation to have, is that everything breaks down to +1. And all of math is counting, and all we're doing is various ways. It's like adding numbers together, gathering together is just fancy counting +1. And that's a really great recognition to have. So it's really good to break it all the way down to 1. But there are other ways that we could play it. Now we've got it this far, we could start combining numbers too. So we could say, we could have 4 over here, and we could combine 2 plus 2. So we have 4 plus 4 plus 1. Mm-hmm. And you can start combining over here. So there's ways that you can break them down. You can add them back together.
Mm.
So because all we're doing is saying that there's a quantity over here and a quantity over here. And the important thing in all of this is that there's an equal sign, and that equal sign never lies. That's telling the truth, that this quantity, because we can gather them together and see that indeed these are the same. So once we figured that part out, because we're going to come back to these rods again. Okay, so we have, let's do this. What was our thing? 3 plus 6 is 9.
Yeah.
3 plus 6 equals 9. And we want to make this really big and center it. Okay, so now we're going to do this on paper. So we've done it with the rods, and now we're going to do it on, theoretically on paper. If I had a big whiteboard, we'd do it on a whiteboard. But this is our pretend paper, and we're going to do the same thing here. So we're going to do the same, just break down a number into another way to say it. Now, you don't just have to make them smaller. You can add any way you want to say it at all. You can add fractions. If your kids can't do fractions yet, you wouldn't add fractions. But if they can do fractions or multiplication or division, you can write it any way you want to say it. But you can only remove one number and replace it with another number.
Okay.
All right. So your turn. So Jeanette, it's your turn.
Okay, so 3 plus 2 times 3 equals 9.
Yeah, I'm going to do it that way. Okay, Andrea? Let's do 24 minus 22 plus 3, 2 times 3 equals, yeah, all right. Jeanette, your turn.
Could you make it 25 minus 22?
No, I'm sorry, I can't. It's a bad morning. I haven't had coffee yet. Now I can. Yes, I can.
Okay. So 25 minus 22 plus plus the square root of 9.
Okay. 25 minus 22 plus, oh, you can't do the square root of 9. Oh, well, you could do 2 times the square root of 9. 2 times.
Oh, okay. Right, I see. Yeah, yeah.
Yeah. Yeah, I'm just catching your mistakes like you cut mine.
Yeah, yeah. No, no. No, I
Okay.
told you. This is good for me.
Okay. Square root of 9.
Equals 3 squared.
All right, your turn, Andrea.
1/5 of 125. Is that how you say it in English?
Okay, yeah. A little translation trouble into English. You know what? I think it's perfectly fine. That there's 1/5 minus 22 plus, I'm going to copy, paste. Okay. All right, my turn. I'm going to do
Oh my gosh.
Do you see how this all just works?
Yeah, but I had no idea that I don't even know how to say it. The 3 to the 5th minus the 3rd. Is that how you would say it?
Yeah.
I didn't even know that
I
existed.
could even do this.
Know what
I
I
could even
mean?
do, I could do half of 4. I could put half of 4 up there.
Oh, wow.
I was going to do half of 4, but then I was going to have to insert another fraction up there, and I didn't want to. just the having to click on this stuff, that's why I didn't. Okay, let's do a couple more. We'll do one more round, and then we're going to convert these into rod lengths.
Sorry, Sonia. Please first delete one plus sign you have there.
Oh, okay. Oh, yeah, I see that. Copy and... All right, what are we replacing? Jeanette, it's your turn. I'm going to do one more full with all 3 of us.
Oh. You see, this is really at my edge right now. Like,
no, you're not. It's not at your edge. So like slow down. So this is
Okay.
good. Slow down. All we're doing is replacing one number.
Okay.
Any number. You can replace the 9. You can replace the 5. You're just replacing it with another way to say it.
Okay.
So I want you to replace the 5 and the 3 to the 5 minus 3. Just give me another way to say 5 and the 3 to the 5 minus 3.
Another way to say 5. Okay, so a nice easy one for me. Would it be...
Just
you
can do whatever you want. Just give me a replacement for 5. It's okay if it just comes out to be 5.
Would 1/25 work?
1/25 of
25?
1/5 of 5? Or 1/5 of 25?
1/5 of 25. Is that right? I don't even know, you see. I'm
Well,
guessing.
how many 5s? Okay, so let's think it through. How many 5s are in 25?
5.
So you need one of those.
Yeah. So
Okay.
1/5 of 25.
Yes. You can do that.
I can. Woo.
Come on, give me back here. This is why I didn't want to do the fraction up there, because I wasn't sure how this was going to work.
Oh, sorry.
That's okay. I'm going to make it work just for you.
My special day today.
There it goes. 5th of... Oh, no, that's 25. There we go.
Awesome.
And we're going to put a parentheses around that just so that we know what goes together.
Uh-huh.
And look what you did.
With help, much appreciated. Thank you.
But all we did was replace a 5.
Yeah.
That's all we did was replace the 5.
See, I just look at it and it just blows my mind.
Right, and all we're doing, so the reason we do this with our kids, and the reason we do this a lot lot with our kids is so that, especially kids that have been regular school, is to take all the fear out of this.
Yeah.
It just blows your mind, and we can actually, like this, all we're saying, all this is saying, this down here is just saying 3 plus 6 equals 9.
Mm.
All right, Andrew, your turn.
For 22, 10 squared minus... Am I allowed to do that?
You are a big girl. You are allowed to do whatever you want. That's how I...
So 10 squared minus...
Now the question is, how are you going to get back down to 22?
Mm.
I want a longer one.
You have a longer one, what?
I want a longer expression.
I'm going to put a parentheses around this because I feel this is going to be a big issue.
Okay, minus 3 times 30 plus 12. Minus 3 times 30 plus 12.
Plus 12? Yes. Yes, you're right. Yes.
Wow.
Okay. And I am going to copy and paste this. Okay, so I want to bring it back. So we're going to maybe make this one go over. Okay, hold on. Okay. So I'm going to not be that dramatic and show off. If Yugen were here, she would do that. That's what Yugen would do. She would show off. I'm going to do something like 3 times 4. Oh, yes, I did mean 3. I actually said 3. Okay. All right. So now what I want to do is write these, and we're going to replace all the 5s with the letter Y. So what we're going to come down here. So the letter Y is because Y is a yellow rod, right? So
Okay.
you're going to start adding some variables in here, if we can get there. And 3 times 4. 3 times 4. All right. So now we've added a variable. What I also want to do is, so let's say that Y is 5. What is 10 going to be? All right, the next one's Jeanette's.
Sonia, just a moment, please. Put a bracket after 3 times 4. There's a bracket there.
All right. Okay, so we've got 2 5s there. Jeanette, how many 5s in 30?
Sorry, say that again.
How many 5s in 30?
25 and 30. So 6. So then that would be 6Y.
Yep. But not 300 at 6Y. All right, so over here we've got 5Y. 5y.
What about 125?
Well, I was getting there last. It was the largest 5. That was on you.
Yes.
Well, there's 25s and 100. Yep. Look what we just did.
Wow.
Isn't that beautiful?
It's, yeah, this is, yeah.
I just think it's pretty to look at. Look at that. So what if we want to replace the 3s with something? So what are we going to play with? A green.
Okay.
We could call it a green, but what if we called it X?
Okay.
So then this is going to be, oh, this is really, okay, so this is going to be X. So what is 6 going to be, Jeanette?
So 2xy, that would be like this.
Need another X here. X. And another X here. X. Oh, it's getting bigger than my screen.
Yeah.
And Andrea, what's this going to be?
3x, actually x squared.
We could do X squared. I was going to do 3X, but we could do X squared. X.
Or x times x, right?
Interesting.
It's not going to let me. You have to do it really hard. I'm not doing it, Andrea. I'm not. Sorry. Okay. Oh, right. Let's do X times 3. Yeah, we can do that. Let me make this a little smaller.
Yeah.
Yeah. Yeah, this just prevents me from having to look at that. Oh, we do. It's out of my screen. Hold on. I have to shrink it down just a little bit more. Look at that, Jeanette. Look what you did.
It's like some crazy scientist's blackboard out of movie.
Okay, but you see what happened?
Yes.
You see how this was like, we just built this from the ground up.
Yeah. It blows my mind.
And here's the other thing. Look at this. We could do the 9 separately, but all we're saying is that this thing here, this short little thing here, is exactly the same as all of this stuff over here.
Yes.
That those two are saying the same thing. How cool is that? I just think it's, I'm just very proud of just looking at it.
Yeah. I'm making notes too. Oh my gosh. So is one of the purposes also at this stage to do things like this, to just take that fear out of it too?
Yes, for both of you, for all of you, especially kids who come from public school. But the other reason for doing this is so that you can understand, like what we do is we teach math and we do numbers. And then you get to algebra and you just do letters. We replace something, but you never really see the connection to how all of this stuff is related. Like, how do we get these things? What are we actually talking about? They just give you this endless thing of problems, and you never build these things from the ground up, so you see what's going on. This is not thing. When you see it on a board, you say, oh, well, I know I've built hundreds of these. I know how to solve this. This is because you've built, and then the great thing is that in 2 weeks, you take this last line and you give it back to your kids and you ask them to solve it. And the other thing that happens, now we can make another change. So we built this and we said that y is 5, and x is 3, right? There's no reason why y has to be 5. What happens if we change those numbers?
Right.
So can we figure it out? And then what does our equation become? Is it still equal if we change the numbers? Will it still be equal? I don't know if it'll be equal. Maybe it will, maybe it won't. Maybe for some numbers it'll be equal, maybe for some numbers it won't. Can we come up with a rule and find out if it'll be equal or not? Maybe this is only equal for the numbers 5 and 3. Maybe not. I don't know. I have no idea. We could find
That's a really good question.
Right, and that's all you're doing is when you sit down, and so I say, well, we're talking about taking these things and not making them like worksheets. So I'm saying you need to go through these questions. So I think I sent out, I'll send it to you if you don't have it. I have a parent-child notebooking page, and it has these questions on them. Like, what can we change? What can we rename? What happens if we do this? Like, what's going to happen? So we changed it, we renamed it, and now let's plug numbers back in, and let's see what happens. Is it still true? Is it always true? Should it always be true no matter what those numbers will be? I suspect it'll be true, but I don't know for sure. So, and you don't know for sure, and you don't have to know for sure. Like, isn't that fun? Let's find out.
Yes.
Instead of like they have to, you could do one problem. This is one problem. And you're going to go all the way from, and your kids can do this. Your kids at 8 and 9 can do this.
Yes.
Right? And we can go through all of this. We can figure out, we know how we got here because you have every single step you copied. So you know how to work your way back because they have all the steps there. They wrote them out themselves. They didn't have to memorize them. They wrote them out themselves. And so you could give them this line right here, this line right here, and they could work this back out to get back to 3 plus 6 equals 9, or that each side is 9. They could work that out themselves. This one here, you can take this and go in all kinds of directions when you're done. So you're going to give them back their own work. So like forget like you writing problems for them, just give them back their own stuff.
Yeah.
And they wrote it so they know they can solve it. And if they can't solve it, you can give them back all the steps that they wrote to figure out how to get there by themselves.
Yeah.
This game is amazing.
It is. It's truly phenomenal to think that first line and the last line is saying the same thing.
And you didn't have a panic attack.
No, but like I say, it was definitely, it's uncomfortable.
Right, because all of a sudden we started putting stuff in there and it's a language that you don't understand.
Yes.
But that's all it is. It's just, but once you understand it, this isn't hard. And that's why I made you do this one with the 3 to the 5th. Like,
Yeah.
I wanted you to put something in there deliberately that is not something you're used to seeing.
Yeah.
So once you see how you build it, this down here is not scary at all.
Yeah.
So all this is saying is 5, right? If we take out this y and we take out that y, we can see how we get the 5 there.
Yeah.
We took one of something that we multiplied by the same number. Well, then it's just the same number.